So you can see here on this panel that if we sit in a telescope on Earth and we look at a distant galaxy... So our exhibit is talking about the ingredients of the universe. What we're stressing is that only about 4 or 5% of the universe, so 1 in 20, is actually stuff we understand. The other 95% is stuff that we know, well, we think we know about. We can measure its effects on what we can see, but we don't really know what it is. So there's dark matter and there's dark energy are two things that, although we can see their properties, we can't actually see them directly. We can only measure them indirectly.
It seems a bit that the universe evolves like a meal that you cook, where you put in water first, and then the pasta, and then the salt and pepper, and then it gives a good meal. And when you put too much pepper, you can't eat it. When you put no water, you can't eat it either. And a bit more particularly, we tell them that the universe mainly consists of 3 things. One is the visible matter, which is everything what you usually know. Humans, the Earth, the clouds, the stars, the galaxies. Then there is something else, the dark matter. It behaves just like visible matter, but we can't see it. And then there is a third thing that has an energy, but doesn't attract things like matter does, but it repels everything.
So what we've got is we've actually got a computer simulation where you can actually set up your own ingredients of the universe. You can set up how much of these 3 ingredients there are, and you can simulate the universe and see how it compares to what we see in our actual universe. And that's a basic version of what scientists really do. They adjust the parameters in their simulation and see whether it matches what we see. This isn't matter. This is this weird thing. We don't know what it is, but what it does is it pushes everything apart and it stretches space. So everyone on this stand today is in Oxford Astrophysics, the Astrophysics Department of Oxford University, and we're all astronomers and astrophysicists of varying types. You've got some people who are theorists, some people who are observers, some people who are experimentalists. So I'm an experimentalist. I help build telescopes, design and build telescopes. Other people actually go and use telescopes all around the world. They collaborate with organisations worldwide. There are telescopes in Hawaii, in Chile, in the Canary Islands, and Australia, and India that people actually go to and use. I mean, fantastic places to visit. And they get the data and then use that. And then there are theorists who actually run the simulations of the computer and see whether it matches with the observations. The aims of this is to get across cosmology to people and explain that we don't actually know much about what the universe is made of. We've got lots of ideas, we've made lots of observations, but there's a lot of work that needs to be done to actually finalise what the universe is made of. And we may never actually do it, but we certainly hope to.